Hey man, great to have you. The video you're watching right now, this one, is probably the video that I would have liked to watch the most when I was a beginner programmer. And that's because there are a lot of aspects involved in building a really reliable, scalable, fast API. And I know a lot of those are buzzwords, right? Everybody says their code is like clean, scalable, maintainable. I know they're buzzwords, but I can prove it because I don't want to sell you any false ideas in this video, any false claims. This is a tool that I launched about 2 days ago or 3 days ago, and since then it has gotten tens of thousands of requests. We're gonna go through the entire dashboard, through all the numbers before we're gonna even start the code. It's gonna be really interesting, by the way. The tool is called Profanity API, and usually you use something like AI, which is really slow and expensive to detect profanity in user input. But it's also so important because if you have an app with any kind of user input, you kind of need to do these checks. Otherwise, your app is gonna be a very big dumpster fire of profanities, and you don't want that. Basic idea is you can input any kind of text on the website or directly make a request to the API, right? And then the API tells you, is there a profanity in here or not? The idea is pretty simple, but people really like it. I'm so happy to see it. And that's exactly what I meant in the beginning. This is what I would have loved to see as a beginner programmer, how to write really reliable, fast stuff. And that's exactly what I'm gonna show you in this video. And I'm not gonna keep talking about it. Let me show you the numbers, how many people requested from this API, how well it handled everything, and then we're gonna build something really, really cool together. All the data that you need to follow along is all there in a GitHub repository, totally free to follow along. You don't need any credit card, nothing. We're just gonna have a lot of fun in building something really cool together right now. So let's get started. Okay, and before we actually write any kind of code, I just want to kind of show you around the Cloudflare dashboard. So what actually happened, how many requests did we serve with the Profanity API? It kind of says on the website, right, almost 100,000. In reality, it's much more because the thing is, this only tracks requests that are made from the actual website and not requests that were made directly to the API, which are a lot more actually. So I called this the example. We're gonna deploy this together, step by step, to Cloudflare Workers, by the way, which is extremely scalable and it's also extremely fast. So I'm just having a really good time with Cloudflare Workers recently. It's a lot of fun. And if we take a look at the last week, that's gonna load some data for us. We can see in total there were about 215,000 requests, and there was one big peak, which I assume was like a DOS, maybe somebody accidentally DOSed the API. I'm not sure what happened here, but if we actually go to request count, we can see 84,000 requests in 1 hour. I mean, this was kind of like 1 minute, right? But it shows it for the single hour. That's probably not legit, right? That's way more than the others. But the cool thing is, as you can see, the API handled it absolutely no problem. From 215,000 requests, there were 10 errors in total. I'm not sure why exactly, but that's not a lot. You know, that's a pretty damn good error rate if I've ever seen one. And we got 45,000 requests here. Anyway, so we officially served about 100,000 requests over these last kind of 2 days, and unofficially above 215,000, which is awesome. Right? And you're gonna learn in this video exactly how to build something like this, right? The exact API that we're using under the hood here, we're gonna build together right now. And as you're gonna see, it's not very complicated. It's pretty simple to get really robust infrastructure to deploy to, which is also just fun to work with generally, right? We can see the logs right here. We can even go into a real-time log stream, right? So as people are using the API, that's literally, people are using the API right now. How cool is that, right? We can see them using it, and yeah, you're gonna learn exactly how to do it in this video. Everything is inside of a GitHub repository. If you go to profanity.dev, also linked in the description, and click on a star on GitHub, that's gonna take you to the GitHub repository. And then what we're building in this video is the vector API, just in case if you ever get lost. By the way, you can start the repo, thanks. Only if you want, right? If you want, you can start. Anyways, what I'm trying to say is if you get lost anywhere in this video, you can follow along right here in the GitHub repo linked in the description. Awesome, so let's get building. Let's build the Profanity API together. It's gonna be hella fun, and we're gonna start right here on our desktop. So let's go into our, first things first, into our command line, right? And we're gonna do this from scratch, no We're gonna use a framework later, but we're gonna start from scratch, okay? So let's navigate to where we want this API to live. And for me, that's always on the desktop. And then we're gonna say mkdir, which is make directory. And we're gonna call this, for example, let's call this profanity-API and hit enter. And then let's cd into, nope, that was not the right one, into profanity-API, the folder we have just created. And then let's say code dot. And code dot is going to open up this exact folder that we're currently cd'd into right here in our VS Code terminal. And of course, as you would expect, this is a completely empty folder. Now let's get rid of that sidebar, and inside of here we can open up the terminal, and let's do two things. So first one is going to be, let's say npm init-y, and all that's gonna do is, if we take a look at the folder structure right here, that's gonna create a package.json for us with all the default options enabled. Beautiful, we don't need to worry about that anymore. And then second thing is gonna be tsc-init, and that's gonna create a ts config, a TypeScript config.json for us. Okay, and in order to understand what we're gonna do next, let's take a very quick look at how this works. So how does a profanity API work under the hood? So how this works is we have a list of swear words, like word 1, word 2, word 3, and why is there like a red underline here? That, anyways, we basically have a list of swear words, right? And when a user input comes in, user input, right, we can basically take a look at if it matches any word in our list. But the beautiful thing is it doesn't, and that's the very big difference to just keeping this list in memory and then checking this every time a user input comes in, because we're going to do this with a vector database. The user input can be semantically similar to the word we have in our list that we keep track of in a vector database and still be recognized as a swear word. So for example, if we had this word right here, right, it doesn't exactly match this one or any other word that we have in our vector database, right? There's a G at the end here, right? And it's not in the user input. So this doesn't match exactly, but the word has like the same meaning, right? Same thing. And a vector database that we're going to use together in a second is actually able to catch that and, recognize that, hey, this is the same meaning, same thing. That's a profanity, right? We need to flag it. Whereas if you compare this literally, right, then of course it would not get flagged. And that's the beautiful thing about a vector database that we're going to use. And the thing is, in order to be able to have these entries in our vector database to check against, and as you can probably imagine, this also means, well, we need a long list of words that we want to flag as profanities, right? And we could just write one ourselves, right? But what I did is I downloaded one from the internet, as you always do, right? And then I modified it to be more, like, to be better, to be more accurate, right? And the way we get this list, this is the only thing we're gonna grab from the GitHub repository. It's under the profanity.dev, then the vector API folder. Go into there, and then it's under training_data.csv. It's a comma separated value file. And it's literally just a very long list of profanities, right? That we can then semantically, not lexically, so not by literal match, but by meaning, check against with our vector database. So let's copy all of this file. You can also just press the copy raw file up here on GitHub. That's, again, the only thing we're going to grab from the GitHub repository, and we're going to use that as our dataset. So let's call this training_dataset.csv right here in our VS Code, and that's literally just paste this in, right? And there's no comma separated thing in here. It's literally just the text and a bunch of swear words. Beautiful. Okay, with that in place, we can actually get started on creating or long list of profanities in our vector database. Now, in order to be able to input these in our vector database, well, first, what's the first step, right? Step 2 is we need a vector database to put this in. Step 1 is we need to be able to read this CSV file inside of a script, right? So let's create a new file in our directory here, and that's called seed.ts. And if you're wondering why it's called seed, that's just a convention for anything that put stuff into your database one time, that you run once, and that's gonna fill your database up. And in order to work with CSVs, there's a really helpful utility library that we can install, and that's gonna be pnpm install or npm install yarn add, doesn't matter which package manager you use. and that's gonna be CSV-parser. And that takes a readable stream and actually makes it pretty simple to work with CSV files that we have right here in our database, in our folder, right? Technically, we could even put this into a long JavaScript array, right? This list is not huge. It's about 1,450 entries. That's totally possible to just put it in memory. If you work with like really long data sets, 50, 100, 150,000 rows, you can't do that. In that case, you need to go a bit of a different route. If you want to take a look at the practical implementation of how to work with really large data sets, that's also in the GitHub repository under the Tensor API, by the way. You can take a look at how I did that here. That's like a 45,000 row data set that we use there, but we don't need to do that in here. So in order to read the CSV file, let's get right in code, man. We're gonna create a new function, an async function, and let's call it Parse CSV. And this CSV only takes one thing as an argument, or right here as a parameter, and that's going to be the file path as a string. And it's going to return a promise. Let's give this a strong return type, and it's going to output a row array. Now, what is a row? Basically, that's the type we define ourselves, and we define it based on the stuff that is in our CSV. So because this CSV only has one column, and that's the text, right? We can see it up here. That's what we call all the swear words. In the first row, it's called the text. We can declare that very easily as a TypeScript type, an interface row. And all that's in here is going to be the text property, and that's going to be a string, right? So this text matches the first row in our CSV. That's all it does. And this function, the parse CSV, what happens inside of it? What is the logic? Well, basically, we return a new promise. And if you've ever worked with promises, then you know that if we return a new promise, we get a resolve and also a reject function, depending on if we have an error or not. So the goal of this parse CSV function, all it does is read this data set and turn it into a JavaScript array, right? That's literally it. And in order to do that, we're going to declare a const rows. This is going to be of type row array, because it's literally just an array of a text string property. And then we're gonna read the CSV file and push all the data inside of that array. Sounds complicated? Maybe. It's really not, as you're gonna see, because we can import at the very top the FS, the file system from FS. And in order to do this, we probably need to install the Node.js types, because this is a Node.js thing, the file system, right? So we can say pnpm install at types/node -d, because we want this as a development dependency and not ship this to production, actually, not to be downloaded during production builds. And then we can say fs.create read stream, right? And inside of here, we can pass it the file path that we want to read from, which in our case is going to be the training_dataset.csv, right? And because this is a stream, we can now pipe, which is a really handy utility when working with streams, both readable and writable streams. We can always create a pipeline using the .pipe. And what we're going to put in here is going to be our CSV helper that we can import at the very top, import CSV from CSV-parser. And the reason we can pipe this is because, as you can see, maybe you can see it somewhere here, I'm not sure. This actually takes a stream as well, right? So that's the reason we can just put it in here as the pipe, which basically means, so syntactically, what are we doing? Well, create a readable stream, right, from this data set right here. And as you get the data right here, put it into the CSV already. So that's what the pipe is for. In real time, as we get the stream data, put it inside of whatever function is in here right away. And this CSV file will get a separator of comma, right? Because that's CSV, it's comma separated values. Even though we literally don't even have commas there, I don't think it really matters. And then we can pass it a .on. And whenever we get data, right, on data, we can execute a callback function. And the cool thing is, as we get data, right, on each trigger of this function, we actually get access to the row value right here in the callback function, which now means we can push it right here into our rows. And that's, let's push that rows.push the row in here. And that's how we turn the CSV file into a JavaScript/TypeScript array, right? In this case, TypeScript, because it's fully type safe. We literally typed it out, which is really handy, right? And then on error, that's another event we can listen to. On error, we get access to the error in the callback function. And what we want to happen? Well, basically, we want to reject the promise with the error, right? That's what the reject is for, that we get in the promise constructor. And then on end, when the stream is done, when we reach the last row of the CSV file, in that case, everything went well, right? Perfect. That's exactly what we want. In that case, we want to return the rows array that we have made all this time. And that's how we can do it. We can resolve with the rows array, which means these rows are now going to be available as the return value right here of our parse CSV function. Promised, because this is an asynchronous function. But what this now means is anywhere we can say const, I don't know, you don't need to follow along right now. I'm just showing this to you. It's going to be await parse CSV. And if we pass this any kind of file path, doesn't matter right now. You can see as the return value right here, we get a row array. Beautiful. Okay, let's get rid of that. I just wanted to show you how that works. Very, very nice. Now let's format this and actually put this into our database. And we're going to do that inside of a function that is called seed. And that is just a convention, same thing as the file name, right? If we ever put something into our database. And this is going to be an async arrow function. There we go, perfect. And we can already go ahead and call that function at the very bottom, because that's going to be the main function that happens inside of this file. Okay, so first thing is that we now want to grab the data from our CSV file, because that's what we want to put into the database. So the const data is going to be await, and let's call our function parse CSV. And inside of here, we can pass the file name of where the data lives, right? So in our case, the training_dataset.csv. Perfect. Let's already log, actually no, let's not log, let's log this out. That's going to be just a very long array, but just to show you what happens, let's just do it. Let's, yeah, well, the question now is, how do we execute this TypeScript file? Can we say node seed.ts? Let's try that. No, not really, right? That doesn't work. Cannot use import statement outside a module. This is a TypeScript file. We can't just execute it with node. The way we do this is by using a super handy utility, and that's pnpm install, npm install yarn add, doesn't matter, tsx. And then as a development dependency, we won't need that in production. It's a extremely simple thing. All it allows us to do is to say yarn tsx seed and hit enter, right? That's just going to execute our file. As easy as that, nothing we need to worry about. And that's going to log out all the stuff in our CSV file that we now have access to right here as our data. Perfect. So we know this works now, right? And now we can actually go ahead and put this data into our vector database to then be able to search for or to filter user input. And we're going to do that inside of a for loop. By the way, we can get rid of the sidebar. We won't need that right now. And the iterator for this for loop, let's call I, right? Not index. And then how many loops do we want to do? And the answer is for every row in our data, right? And that's literally just the data.length. That's the amount of rows we have. And the purpose of this for loop, we can get rid of the default boilerplate stuff that it puts here for us. The purpose of this for loop is that we can now batch requests in order to seed stuff into our database, right? We don't want to fire a network request for every row in here. That would be kind of inefficient. What we can do is define a const step, and let's say this is going to be, for example, 30, right? So we're going to batch 30 requests to our database all together at once, which is much more efficient, right? And in order to see which chunk, const chunk, we have to fire for each database entry, this is just going to be the data.slice, and we're going to slice from I to the I plus step, right? So that's going to be the current chunk we want to index into our vector database. And the vector database expects kind of a certain format of data. So let's kind of prepare the data to index it into the database. The const formatted, let's say, is going to be the chunk.map. So for each row in the current chunk, we get access to two things. First off, the actual row content. And let me scroll down so you can see this easier and also zoom in a bit. And then secondly, the batch index, right? We always get access to that as the second thing in the map function. It's always the index, right? If we hover over this, you can see first thing is always the value, second thing is always the index, third thing is always the array. You rarely need the third thing. I've never really needed it. And inside of this function, first of what we can do is directly return an object by wrapping this whole function in parentheses. So all this means is now it expects an object to be in here. And that object is going to have a data property, and that's going to be the row.text. Right, fully type safe, by the way, because we typed this out ourselves. Second thing is going to be the ID. That's going to be our ID for the database. And this is going to be the I plus the batch index. So the I comes from the for loop, and that's going to be 0. Then it's going to be 30. Oh, it's only going to work, by the way, if we say I plus equals step right here, right? Not I plus plus. We don't want to increment by 1 each time, but by the step. So that's why the I is going to be 0, then it's going to be 30, then it's going to be 60, 90, and so on. And then the batch index is going to be the actual index inside of that batch, right? So altogether, we will get IDs from 0 to 1,400, however many rows we have. Beautiful. And then the last thing we want to pass in here is the metadata, and that's going to be a text object with the row.text. Do we have to pass this? No, the metadata is completely optional, by the way. We don't have to pass this, but I think it is nice because then in our vector database here in a second, we can very transparently see why text is getting flagged. And it really just helps get a good understanding of your data. And we're already, by the way, we can console log upsert, and you don't need to follow along with this console log. I just want to show you upsert and then the formatted. Let's save that and say yarn tsxseed, and that's gonna batch all 1,400 whatever rows into 30 row requests, just like this, that we can then send off to our database. As easy as that, right? Perfect. That's exactly what we want. And in order to connect to our vector database, that's really easy. Let's head over to upstash.com. And of course, as always, right, full disclaimer, I work here, I work at Upstash. Let me log in here on my second screen. And dude, I think the products are great. Otherwise, I wouldn't work there, right? But I just want to be very transparent. Yes, like I work here. Anyway, and dude, with all 200,000 requests or more even coming in, the total cost also for indexing everything, right? I had to do like V2, V3, V4, there was V1. I did a lot of data stuff with Upstash Vector, and the total bill is like $4.85, which is pretty nice. Anyways, I just wanted to tell you that maybe you find it interesting. How much does this actually cost if you serve like 98,000 requests or 200,000 unofficial requests, I guess. Here's your answer, right? It's not expensive. It's pretty nice. Let's create an index together, and let's call this profanity-API, and let's create this in the Ireland region because that's closest to me. As the model right here, we're gonna choose the where is AI UAE large. That's just gonna fill out everything else for us, which is very convenient. And then let's hit next. I'm going to select the pay as you go, but you can totally follow along on the free plan as well if you want. Upstash has a pretty good free tier. I was on it for the longest time, so that definitely works. And then as easy as that, that's going to give us the credentials we need to connect to our database right here. So let's grab this. Let's grab the index, and let's also grab the import statement from way up there. Let's head back into our code and then paste it at the very top of our file. Right, so let's move the import to the other imports. I just think it looks cleaner. And that comes from a package, the index right here. We're importing it from a package that currently doesn't exist in our project, and that's at upstash/vector. So let's go ahead and install that. npm install at upstash/vector. There we go, just a kind of wrapper to interact with our vector database via HTTP. Perfect. And as easy as that, we now have the index, and we can use that to put this data into our vector database. So let's say right down here, await index dot, and there's a method on here we can call, and that's the upsert right here. And we're going to input the formatted, and that's already going to be in the exact format that Upstash Vector expects, which is this one right here with data ID and optionally metadata. And that's already going to work. Beautiful. So let's actually put this data into our database. Let's run our script yarn tsxseed, and ideally, right, that's going to take a bit longer because it fires 30 row batch requests to our database. And let's see, let's go to our data browser right here on Upstash, and we can see 1452 vectors in here. Beautiful, that is amazing. Dude, and that's literally, believe it or not, that's the hardest part of this entire thing. What we're gonna do now is the fun part, and that's building a high availability, very fast, globally available, I know a lot of buzzwords, right? But a really nice API to make this available to our users. So if you were to go to the website and press this button right here, well, of course, that makes a request to an API, right? And that's what we're building right now. So in order to build this API, let's create a new file, and that's going to be called index.ts, right? That's going to be the most important file in our entire, bam, there we go, in our entire project right here. And we are going to use a really nice, I'm having a blast with this framework recently, a really nice framework, and that is called HonoJS. And Hono does two things. First off, it's fast and lightweight, right? It's just nice to work with. And secondly, it makes it really easy to deploy to Cloudflare workers, which we're going to do. I love it. Hono is absolutely goated, right? And we're going to use it together by saying npm install. Again, doesn't matter which package manager you use, and that's going to be Hono. And hit enter. And that gives us everything we need to create a great API. And if you've ever worked with any kind of backend framework, that's going to feel very familiar what we're doing right now. So let's say const app is equal to a new Hono. There we go. And we can import Hono from Hono up here and invoke that. That Hono invocation of the Hono class is gonna return us our app. And this app takes things like app.use, right? Just middleware, same thing as with Express or Fastify or any other kind of backend framework that you can imagine. And let's first off give this the course middleware so we can make requests to this Cloudflare worker from anywhere. And this course, we can also import that at the very top right here, import course from Hono/course. That's just a little helper it gives us. And now let's create the actual API route, the route that people are going to make requests to. And that's going to be app.post. And if you make a post request to the / route, so to the main domain that we're hosting this on, in that case, we get a callback function. It's marked as asynchronous. And this callback function contains the context that Hono gives us. If we hover over this, that's going to be the context type from Hono. And you can basically imagine it like the request, right? It gives us all the data that we need, all the user data, the content type, etc. And the content type is important because that's the first thing we're going to check. We're going to say if c.rec.header, and that is a function we can call, by the way, we can enter the name of the header that we want to get. In our case, that's going to be the content dash type. We want to make sure that is application/JSON. You can only make those types of requests to our API. So if that header, and that needs to go outside of the function, is not equal to application/JSON, right? In that case, we're gonna reject the request. We don't want to answer it if the content type is not right. So we're gonna return, and that's the interesting thing. You know, in, for example, Express, right? We have the request and the response. That's how it works. In Hono, that's a bit different actually. We only get the C, but then we can get both the c.request and also we can return the c.json, which is basically the response. So it's all in one thing in the context, right? And we can return the c.json, and the error is going to be JSON body expected, right? And then the status that we can pass as an object as the second argument in here, the status is going to be 406. There we go. If we Google that, HTTP 406, let's see what that is. Not acceptable. We don't accept that header, right? That's all it means. Perfect. Okay, and let's enter a try catch block right down here where we catch the error. We're going to worry about the error handling later. Now, the first thing that we want to do in here is get access to our vector database. And actually, one thing I showed you in our seed approach right here, where we just pasted the index with the credentials, right? These are very sensitive pieces of information. Usually, this is a very big no-no, right? Just pasting them as clear text into your file. That's generally a very bad idea. I just did that to show you the seeding. Normally you don't want to do that, so we're not gonna do it anymore. We're gonna find a better approach. And that better approach happens inside of a file that is called the wrangler.toml. Now, if you've never worked with Wrangler or a TOML file before, don't worry, it's very, very simple. What is this file? Basically, if we want to deploy to Cloudflare workers, right? Cloudflare workers. Let's see what they are. Let's go to the Cloudflare website. You write the code, we handle the rest. Deploy serverless code instantly across the globe to give it exceptional performance, reliability, and scale. And that's true. It really does. All of these sad things right here. I've had a really good experience with Cloudflare workers. And if you want to deploy here, first off, it's really easy, as you're going to see. Secondly, you use a tool called Wrangler to do it. And I need to spell it right, Wrangler, which is a command line interface to deploy to Cloudflare workers. So that's why this file that we just created is called wrangler.toml, because it's specific to this Cloudflare tool, right? So it really is not rocket science what we're doing right here. Let's give this a name, and that's gonna be the name of this API route, how it appears in our Cloudflare dashboard. Let's say profanity API. I'm gonna say demo. You don't need to say demo, but I might already have a project called profanity API in there. And then this takes a compatibility, very hard word, by the way. That's called compatibility underscore date. And this is going to be equal to, let's say, 2024/04/16, right? So just a very recent one. And here comes the important thing, right? We kind of need to pass these. Here comes the important thing, right? In order to be able to access our vector database inside of the Cloudflare worker runtime, which our API runs in right here, we need to pass the environment variables that we want access to right here as the vars into our wrangler.toml. So this is the same thing as like a .env, right? Just for Cloudflare, same thing. And we're going to declare two things in here, the vector underscore URL, and this is going to be equal to, and then in quotes, that's important, by the way, it needs to be in quotes, that's going to be our URL right here to connect to our index from the seed.ts. Let's simply paste that in there. And then we want the vector underscore token. Same thing, equals in quotes, and that's going to be the token we get from right here that we use to connect to our vector database. And that's already it. That's our wrangler.toml, as easy as that. And all that did, right? All we can do now is get access to these variables right here in our index.ts, in our actual API. And we get access to them by saying const, and let's worry about the destructuring later, is going to be equal to env. And this env is also a helper that we can import from Hono. So at the very top, we can say import env from Hono/adapter. There we go. Let's format this file. And this is a function we can now invoke with the context that we get passed from Hono. And now Hono doesn't really know what is in our environment variables, right? How would it? It's in a different file. It has nothing to do with this API. So we need to kind of tell it. And we do that using a TypeScript type. Let's say type environment. Let's help Hono to know what we're passing it. So basically, we're just typing out the wrangler.toml, the variables we pass in here, which is a vector URL as a string, and it's also a vector token as a string, right? And we can simply pass this environment as a generic into this env function we get from Hono. And what that's going to do is make this fully type safe. We now know that we have the vector token and also the vector URL to destructure from the context environment. Perfect, which now means we can connect to our vector database inside of our API. Let's say const index, and that's going to be a new index we get from Upstash vector. And inside of here, this takes three things. First off, the URL, and that's going to be our vector underscore URL. Secondly, the token, that's going to be the vector underscore token. And last thing, and this is only important because we deploy to Cloudflare, that's going to be the cache of false. Cloudflare doesn't support the cache header. That's actually a fix I implemented myself into this Upstash vector library because it doesn't work on Cloudflare if we use the default cache. So we gotta disable it. Okay, now we connect to our vector database. Beautiful. Now we have all the resources we need to answer the user request. But before we do that, very important, any API needs to have input validation, right? If the message that the user is sending here is way too long, then of course we're not gonna answer the request. We need to make sure we are safe to answer the user, well, safely, I guess, right? And the way we do that is by first getting access to the post body content. Let's say the const body is gonna be equal to await c.rec.json, and that's how we get access to the JSON body. And then we can destructure the message let. By the way, not const, you're going to see why in a second. Let's worry about the destructuring later, and that's going to be equal to the body as message string. So we're just typecasting this in here. We're expecting a message property on the body, and then we can destructure the message from here. And if we don't have a message, if the user did not pass such a thing in the post body request, then we're not going to answer their request. How would we if we don't have the necessary data? In that case, we're going to return the c.json and in here pass an error, and that's going to be message argument is required, period. And then the status we can pass as the second object. Status is going to be 400 bad request. We need that in order to answer your request. And now in order to make sure that the user input is safe to answer, we can say if the message.length is larger than, for example, 1000, right? If it's a super long message, in that case, hell no, we're not gonna answer it, right? In that case, we're gonna return a c.json, and that's gonna say error. And then, for example, as the error string, message can only be at most 1000 characters, period, right? And then as the status, we're gonna send 413. There we go. You could also send 400 bad requests. That would be totally valid as well. Let's Google what 413 means. Let me show you. HTTP 413, content too large, right? What you're passing in is too much. We are not gonna answer it, but HTTP 400 is just fine as well. Honestly, these HTTP status codes, they don't matter a lot. It just doesn't really matter. It's just kind of nice to find the right ones. And now as for this part, why did we declare the message as a let and not a const? And that's because we're gonna mutate it right now. So the reason we're doing this is because the underlying models that we use for creating the vector embeddings, sometimes they have a bias, right? What we're expecting as the user message is something that could be a normal message, or it could also be a profanity, right? That's the entire point of our API. There could be profanities in here. And if you click profanity check, then of course we want to know that, hey, this is in fact a profanity. And why is this? There we go. Why did that take so long? What? Let's try that again. Okay, that's faster. All right, that's good. We want to detect that this is a profanity, right? So it could very well be in the message. Sometimes the underlying models have a bias, and that's why we are going to create a const whitelist at the very top of the file. And these are just words that are not swear words, that are inappropriately flagged. So if one word, for example, would be swear, for some reason, the underlying models sometimes think that this is a swear word, even though it's really not. This is not a profanity. So this only happens in very rare cases, so you rarely need this, but I do want to show you like how you would go about implementing such a thing. I just think it's interesting to do, and it's also realistic. I want to show you this API as it already is. So we're gonna filter the message. The message is gonna be equal to message.split, and basically we're gonna split the incoming user message at a regex. So double slash, and then in here a \s. So basically at any white space, like spacebar, we're splitting the message. We're gonna apply a filter, .filter, and for each word that is in the incoming user message, we're gonna return not whitelist.includes the word to lowercase, right? And not to local lowercase, but just to lowercase. So we get case insensitivity. So for example, if the user input contains, for example, the word let's say swear in caps, right? We want to kind of filter out this word because it would be flagged inappropriately, right? That's what we're doing right here with this filter. We're kind of filtering out this word. So what the underlying model then sees is just this, right? Because we know that this word is safe. And lastly, we're going to join this back together using a spacebar. So we didn't really change anything. We just excluded all the words where we know they are safe from the whitelist. Perfect. And now we're all ready to actually split this into chunks. Okay, little cut there. I'm back. Bada bing, bada boom. My cat just walked in the room. Anyways, let's continue. So why do we want to chunk this? What is the purpose of chunking? So basically, if we take a look at this, right, we have a list of words like the F word or this one, whatever. And if we just had the entire user text, which could be, it could be really long. Let's take some lorem ipsum, so I can show you what the user input could look like. So for example, let's say that user input was this. Oh, why does this look so bad? No, that doesn't work. But just assume that the user input was something really long, okay, a really long input. And basically, if we take the entire user input, however long it might be, for example, the 100 words here, or something similar, and compare it to one word each, right? To the F word, to the, I can probably say shit, right? YouTube is not gonna demonetize me. Then chances are it's not going to work very well, because this could be any length. And if the meaning, the semantic of the user input is very different to the actual swear word, which is very likely the longer the text is, then the flagging is not gonna work very accurate. Right? So if the user input was this as like one very long sentence, that wouldn't work very well. That's why we chunk it. So we take, for example, 3 or 4 words each, and each chunk of 3 or 4 words, we then compare to the words we have in our vector database. Essentially, right? If that sounds too abstract, all we're doing is taking the main user input, the big message, splitting it into chunks, and then verifying if the chunks contain swear words, which is much more accurate, right? And in order to do this, let's declare a const and an empty array for now. We're gonna destructure this in a second. And this is gonna be equal to await promise.all. And this promise.all array takes 2 things, because we're, for maximum accuracy, going to chunk this into 2 different pieces. First off, we're gonna check for each word. So we're literally gonna take the user input, and for each word that it has, we're gonna check, is that a swear word or not? How does it compare to our vector database? And that's actually gonna be the much more easy step. So let's call this, for example, split text into words. And now, of course, that function doesn't exist yet. We're gonna declare it in a second, but we can already pass it the user message because we know it needs to accept that. And now to declare this function, let's say function split text into words. There we go. And of course, we need to accept the text as a string in here. And this function is going to be that simple. All it does is return the text that it accepts, dot split, and we're going to split at whitespace. So at \s, which is a regular expression, which basically matches any kind of whitespace. So from the text, we get back an array of strings in this case. If we hover over this, we can see that in TypeScript, an array of strings, and same thing is going to happen for the larger chunks, right? So what we're achieving with the split text into words is basically for each word in the user input, we're checking, does it very closely match one of our entries of swear words? And what we're doing in the larger chunks is taking like 3 or 4 words and then seeing, is it like toxic? Does it match larger parts of our vector database? So both in word level and in like more overarching semantic level, we scan for profanities, which is much more accurate than just doing one of those, right? Just scanning for words or just scanning longer text. I've tried both of them in the Profanity API in production, and this is the approach that by far worked the best. So we're not only going to split into words, but we're also going to say split text into semantics. Semantics, there we go. And that also takes in the user message. And now, of course, the split text into semantics function also does not exist. So let's go to the very bottom and declare this as an asynchronous function. Split text into semantics. That's gonna receive a text as a string, just like the split text into words, right? Exact same thing. And then let's open up the function to handle the actual logic. Now, first thing we're gonna do is, well, if you don't know what semantic is, it's basically the meaning of text, right? What does it mean? Is it toxic? Is it not toxic? Like what's between the letters, right? What is metaphorically said in the text? And if there's only one word, then chances are there are no real semantics in that word, right? So if we check for text.split and then we split at whitespace, so basically we're checking if there's only one word, right? If text.split whitespace.length is triple equal to 1, we only have one word. In that case, we're just gonna return an empty array. There's no point because we're already handling that check through the word split, right? No point in doing the exact same chunk twice. So that's what we're avoiding here. And now to actually split the text, there's a super useful utility we can use for that. Of course, we could implement the entire algorithm ourselves. We don't need to. There are good solutions for that. And one of them is called LangChain. And let me check if it's LangChain.js. No, it's just LangChain. And let's say npm install LangChain. There we go. And we're going to use one utility from this LangChain library. And that utility, great, we can get rid of that, is going to be at the very top of the file, the recursive character text splitter. Super long name, from LangChain/text_splitter. Very helpful utility, because check this out. What we can now do is say const semantic splitter is going to be equal to a new, and then whatever that really long name was that we just imported, right? Just copy and paste it. And this is basically a class that we can invoke. And in the constructor, it takes 5 options. And what we're going to pass in here is first the chunk size of 25. And this is letters, by the way. So about 25 letters. This is not super exact. The separator is going to be an array, and we're just going to pass a space bar in here. So it means it's going to separate the text at the word level at the space bars. And then the chunk overlap, which is really important for keeping context, we're going to set to 12 characters. Beautiful. Okay, that semantic splitter is going to be very useful down here into our function in the split text into semantics, because what it allows us to do is declare a const documents, and this is going to be equal to await semantic splitter, what we just created together, dot create documents. And this takes an array, but the array is only going to have one element, and that is going to be the text that we pass into this function. And now the actual chunks from that, the const chunks, are going to be documents.map. So we're going to go through each result, and for each chunk we get in the callback function, we're going to return the chunk.page content, which is just the actual chunk, right? It has some other information we don't really need, like the metadata. Who cares, right? We don't care about it. And then we simply return the chunks from this function. Beautiful. Let's go back to our promise.all, and let's actually comma separate these because this is an array. Perfect. And because we have 2 functions in here and they both have a return value, we can now directly destructure in the array. So the semantic chunks, and if we left it like this, that would actually be a bug, because the thing is, the order matters. If we have the split text into words function first and then the semantics, what would happen now is that the return value of the words would now be assigned to the semantic chunks, right? And if we also destructure the word chunks, then the semantic chunks would be assigned to the word chunks, because first, second. So the order would actually be wrong here. So let's switch them around using Alt and arrow down. So first off, we get the semantic return value and assign it to the semantic chunks, and then the word chunks from the word chunks function. Beautiful. Okay, let's hover over these to see both should be a string array, and they are perfect, which allows us now to actually check for profanities. And we're going to do that. We're going to keep track of profanities inside of a set. And we're going to call that set const flagged for, which is going to contain all the words that we flag profanities for. This is going to be equal to a new set. And the beautiful thing about sets is that they, by default, do not allow duplicate entries. So if any chunk should be flagged for the same thing, we don't return the same flag twice for the user, but just once, which makes so much more sense, right? And this set actually takes a TypeScript generic. We can tell it what the type will be. And that type will be an object with a score, that's going to be a number, and also a text. And that's, of course, going to be a string, right? And we're not going to put anything at the very end. It's going to be empty for now. And now let's say const vector res, the vector response, is going to be equal to await promise.all. And as always, the promise.all takes an array. And the goal of this vector res is basically ask our vector database for both the word chunks and the semantic chunks, do these contain swear words? That's all we want to do in here, right? Both of these, that's why we have a promise.all. So first thing we're going to do is the word chunks. Does any word in here very closely match a swear word? So does really, is that a swear word? Is long a swear word? Is input a swear word? That's what we're checking for each word in the user input. So we can spread in the word chunks dot map, and for each async, right, we need to mark the callback function as asynchronous because we're going to await something in here. For each word chunk that we get, each word in the user message that they send to the API, we're going to say const and then an empty array. We're going to worry about the destructuring here in a second. Is going to be equal to await index, so our vector database dot query. And we're basically asking our vector database right now, is this closely matching any swear word in our database? So the top K, how many vectors we want to retrieve from our vector database, is going to be 1, because we only care about the closest match, right? This is always going to be the most accurate match. And if we did 5 or something, the rest 4 would never be a more close match than the first one. So we just don't care about them. It doesn't make sense to get them. The data is going to be the word chunk. There we go. And we're also going to say include metadata true, which is gonna include the text metadata. So if we take a look at our database, you can see this right here is the metadata, the original text. And basically all we're saying with the include metadata is if you fetch something from the database, also include this. And that's what we're gonna add to the flagged for set here in a second. Now, what do we destructure from here? That's the closest vector. This is an array because the top k could be like 5, right? In that case, this would be 5 vectors, like second, third, and so on and so on. But since we only fetch one top k, this means we're only gonna ever have one match from our vector database, so we can directly destructure it right here. And now, if the vector exists and the vector.score is larger than 0.95, right? This basically means it's a very close match. So for example, if we had this word right here, which YouTube is very much gonna demonetize me for, then that's gonna be a very close match to this word, right? It's basically the same thing. So that's gonna be like 0.98 maybe. Because it's not literally the same, then it would be 1, but very, very close match. So very close number to 1. So this would definitely match. And if we're checking on a per word basis, we also expect a very close match to avoid false flags, right? So that's why we put 0.95 here, because we expect a very close match on the word basis. And if it matches, then that means that is a swear word, and we're gonna say flagged for dot add. And in here, this is gonna take an object with the text, and this is going to be the vector dot metadata, which we know exists because we said include metadata true. So we can put an exclamation point to tell TypeScript, yes, we are sure, dot text, and we can cast it as a string. And the score this takes is going to be the vector dot score, right? Which is larger than 0.95, which we're flagging this as a swear word for. And then very lastly, as the return, we're going to say return score of 0. And you're going to see why we return a score of 0 in a second. This is going to make sense once we return data to the user from the API. And then second thing is going to be exact same logic. We're going to spread in these semantic chunks and basically do the same thing. We're going to map over them. And for each async semantic chunk that we get inside of the callback function, well, we can basically just copy and paste the logic from the word chunks, because while the chunks are different, the logic is pretty much the exact same. We can get rid of the first line. We don't need that anymore. And then of course, instead of the word chunk, we're going to have the semantic chunk, but we're still going to have the metadata. The only difference is going to be the threshold that we check for, because we now have larger chunks and we care about the overarching context, right? So for example, a larger semantic chunk of the user message, how relatable is it to this word right here? And chances are, because there are more words in here, the meaning is different. It's not going to be 0.98, right? It's more going to be maybe 0.88, I guess would be a better comparison for this, because the word is in here, the meaning is closely related, but it's not the exact same thing, right? That's why the score is going to be lower, and we want to account for that right here, where we check for this. So let's go to the very top of the file and declare something called a const profanity underscore threshold, and set this to 0.86. So when the similarity score is larger than 0.86, in that case, we're going to flag this as a profanity and then replace the 0.95 for the semantic chunks with that threshold. The way in which we add to the flagged for set is going to remain the exact same. The only difference is that we're going to return, instead of a score 0, the actual vector. And we can also tell TypeScript that we know this will exist by putting an exclamation point at the very end. Now, why did we do all of this? And the cool thing we work towards is now, after the promise.all, right, we can check, did we flag anything? And we can do so in an if statement. And we can check for if flagged for.size is larger than 0. So if it is, right, if the set is larger than 0, that means we either added something here on the per word basis, or we added something here on the larger semantic chunk basis. And that's great, because if the set is larger than 0, we know something profane was flagged in the user input, and we can return the response accordingly. So we can return the c.json. You're probably used to this by now. This is just Hono syntax for returning a JSON response back to the user. So the is profanity is going to be true, right? This takes an object, and obviously something profane is going to be in here. The score. Now, what is the score? How profane is the user input? What do we rate it? And there's no direct way to tell from or flagged for, right? So what we need to do first is sort or set. And the way we do that is actually pretty simple. We can say const sorted is going to be equal to array.from. And basically, we want to return the most profane thing that the user input was flagged for, right? That's why we got it sorted. We can say array.from flag for, so we can just literally input a set into an array.from and turn it into an array like that. Super easy, super cool. And then we can just apply the sort function where we get a and b, and we can return a.score is larger than b.score. And if it is, in a ternary statement, we're going to return -1, and else we're going to return 1. And by the way, how I usually do this is either I put here 1 and here -1, or the other way around. Then I try it out if it's sorted correctly or if it's like the exact wrong way. And then you can just change the position of the minus. And that's, you know, that's just how I always figure this out. And because we only care about the most profane entry, we're going to access that at the index of 0. So we're going to get a single object back that we can now use to say what the score is, right? So we can say sorted.score. Beautiful. And to let the user know the text of what this was flagged for, not just the score, but also what is the actual text that we get from the metadata, right? That's going to be this one right here. What is this profanity flagged for? We can say flagged for, and that's going to be the sorted dot, oops, not score, whatever I typed there, sorted dot, and then the text. Beautiful. That's the response if something was flagged. And if nothing was flagged, right, in the other case, else. Well, first off, we still care about the most profane chunk. The only thing that's changed now is that this chunk is not actually profane. It wasn't flagged, right? But we still saved it as the vector res. Now it's going to be below that profanity threshold that we set, because otherwise it would be flagged, right? But the user probably still cares about the score, like 0.8, 0.75, however non-profane it is. It's still interesting to the user. And to find that, that's why we saved the vector res. We can now say the most profane chunk is going to be equal to vector res, what comes back from the promise.all above from all the chunks, dot sort, and same thing. We get A, we get B, and we can simply return the A.score is larger than the B.score, and if it is, we're going to return -1, and if it's not, then we're going to return 1. And we only care about the index of 0 in here as well, so we get back one score number. And what that allows us to do now is to return the c.json, so a JSON response from our API. Once again, you know this by now, is profanity is going to be false because we didn't flag anything, right? Remember, the set size is going to be 0 in the else case, so nothing is actually profane, but the score is going to be the most profane chunk dot score, right? Still very interesting to the user. Now, let's care about the error handling very quick. If anything goes wrong, first thing I always do, console.error the error. And that's useful if you want to debug your real-time server logs. If anything goes wrong, you always get the error message there on your server. It's just really helpful. And then second thing is return a c.json, once again informing the user that something went wrong with the API, right? So first thing we're going to return is an object, and that's going to be the error. And let's say something went wrong, period. And then as the status, which we can pass as the second object right here, status is going to be 500 internal server error, because we're not super sure what went wrong, right? So we're going to send back a kind of generic message, generic status code, and then we can debug ourselves from the actual console.error on our server logs. Hell yeah, dude. And that's it. That's our API. Let's test out if this works. So we can start this API locally by saying yarn wrangler dev and then passing it the path of this file. So if you had a source folder, this would be source/index.ts, but since we have it at the root, it's going to be index. So yarn wrangler dev index, let's hit enter, and it says wrangler not found. So let's say npm install wrangler -d, because we just need this as a development dependency and not actually in production. Okay, let's let that load. Let's clear the console and let's try that again by running yarn wrangler dev index, so the path to our file. Beautiful. Your worker has access to the following bindings. Perfect. And it's ready on HTTP 127.0.0.1.87.87. Okay, I've already went ahead and started up an HTTP client here on the right-hand side. This one is Bruno. You can also use Postman. You can also use your terminal and then curl. Doesn't really matter. And then let's create a new collection. Let's name this profanity test. Pass it a location and let's hit create. Okay, now in here, let's make a new request. The name doesn't matter. I'm just going to input anything. And this is going to be a post request to our local endpoint. And then let's hit create. Again, you can use your terminal, Postman, any HTTP client, doesn't matter. Or even another script in which you just make a fetch request. And let's try this out. So the body, we need to pass a JSON body, and that's gonna contain a message property. And let's say hello world in here. And let's send this request. Let's hit send and see what happens. No response, and we get an error here in our console. Let's see what's the problem. Error, no response. Aha, and I just did some debugging, and that's because we didn't export default app at the very bottom. So that's how Hono listens to the incoming requests, right? So it's very important we do that. Let's clear the screen. Let's try this again by starting up our development server, and don't forget to add the export default app at the very bottom. And let's try this again. Let's make the request. Let's hit send. Beautiful. Is profanity false? And then we also get the score of how profane this is. Let's insert a swear word here, and let's try that again. Let's send the request, and hell yeah, this is profane. Score 1 is profanity true. And if we turn this into a variant of the F word, this would still be, yeah, see, it's 0.98, so it's still very close to the actual word. So a vector database is very easily able to catch that. That's why it's so useful here. And we can clearly see the score is profane, is profanity true, and then what this was flagged for, right? And that comes right here from the set flagged for that we have created. Beautiful, man. Very, very good work. And just like that, we have recreated an API that, let's see, over 100,000 people have used. That is super cool. And I mean, technically like 220,000 or whatever it was, but you know what I mean, right? Over the official website, only 100,000. Still pretty cool. And that's how it works. You now know how to create something similar. And last step, in order to get this deployed to the web, is to say yarn wrangler, or actually no, let's write a script for that. Let's go into our package.json. I want to teach you how to do this properly. Okay, we could just wing it. I want to teach you how to do this properly. Let's create a deploy script, and that's going to handle the deployment of our API endpoint. So this is going to be wrangler deploy --minify and then index.ts. So that's the path we want to deploy. This is a flag. We can pass it to actually minify the code it does deploy. And this is to tell Wrangler, the Cloudflare CLI tool, what it should do. The rest of the arguments we've already passed in the wrangler.toml, right? We could also pass these as flags, like the name or compatibility date in our package.json deploy script, but we can also just define them here once, and then they will always be used automatically. Right? And then all we need to do is say yarn deploy, hit enter. If you've never worked with Cloudflare before, that's going to ask you to log into Cloudflare. And once you did that, you can use the command as it is. Same thing. That's going to upload all the code we have in the index.ts and everything it needs up to Cloudflare. You can see that right here. And then right here, published profanity API demo, and it gives us an actual web URL to use. Let's make a request to that. Hit the arrow right here. Hell yeah, dude, this works. 300 milliseconds. If we try this again, a bit faster, 240, 180 milliseconds, very, very fast response times. And we can accurately see if there are profanities in here or not. And that's literally the infrastructure behind the open source, completely free tool that I launched. I'm super happy with it. And now you know how to build something similar in terms of scalability, in terms of availability, and in terms of speed, because Cloudflare workers are really fast. And dude, I really hope you enjoyed. That's it. That's the build. That's how this works under the hood. If we click profanity check, it's gonna make a request to one of the endpoints we have just deployed to Cloudflare workers ourselves. Beautiful. I really hope you enjoyed this. Hey man, I really hope you enjoyed this video. This project was so much fun to make. And I really hope that it's useful to people, right? This is meant for profanity checking at scale. Right? If you have like a Discord server where tons of messages pour in every minute, then you can't use AI. It's too slow or it's too expensive in case of OpenAI, for example, or both in worst case, right? This is exactly what Profanity API is made for, and I think it does a really good job at that. And now you know the infrastructure behind how to construct really reliable, fast, and cheap APIs. So I really hope you enjoyed. That's gonna be it for me for this video. I'm gonna see you in the next one. Until then, have a good one and bye bye.